Right, so this week, and probably for the next couple of weeks, we're going to be going over um, proportional relationships. A fancy word for that is direct variation, okay? We've done stuff with proportions up to this point, but that's been um, more like calculations and uh, number and operations type thing, and this is going to be more the algebra side of things. Okay, so in this question, it says the table below gives the shipping price for different numbers of soccer balls. Do the numbers in the table represent a proportional relationship, also known as a direct variation? Because in math, we like to come up with fancy words to represent things, I guess. All right, so in this column right here, the x variable, okay, that is represented by the number of soccer balls. So if we're shipping one, if we're shipping two, if we're shipping three, or if we're shipping four, okay. And then the y variable, the dependent variable, is the price in dollars. So $2, $4, $6, $8. And the way that we can tell if a relationship is proportional from a table is you just take, and you have to check this with all of the cases, all right? If every single time you take your y variable and divide it by your x variable, you should get the same number. I'm sorry I'm using all these letters, but this is the notation that pretty much everybody uses. You should get the same number, k, and we call this letter k right here, we call that the, and again, I don't know why they use the letter k when it's called the constant. When it's called the constant of variation. Since constant starts with a C, they use the letter K. I'm not sure, but that's what every book that I've ever seen or every teacher I've ever seen is used. So I'm going to use it too, I guess. All right. So every single time I take the y variable and divide it by the x variable, I should get the same number called and we call that number the constant of variation when it's a proportional relationship or a direct variation. So I'm just going to check in my table really quick if this is a proportional relationship or not. And then we can interpret what that means. So I'm going to first take my first y variable right here, 2 over, and then the x variable that is within that relationship is 1. When I have one soccer ball, the cost is $2. Or when my shipping price is $2, I have one soccer ball. And 2 divided by 1 is 2. Okay, then I'm just going to check it with the other three cases. So my other y below that is 4 over the x variable that goes with 4 is 2. So 4 over 2, or 4 divided by 2, is just 2. Okay, so far so good. We've gotten the same number all so far. Now here, I'm just going to check right here as well. I'm going to take 6, because that's my y variable right here, and divide it by 3. And 6 over 3, or 6 divided by 3, is also 2. Still looking good, like it might be a proportional relationship. All right, or I'm going to go 8 divided by 4, or 8 over 4. That's also equal to 2. Okay, so we would say yes, this is a proportional relationship, because whenever I take my y variable divided by my x variable, or my dependent divided by my independent, I get the same number. I'm almost out of time. I'm going to continue this in a second video